Assalamualaikum warahmatullahi wabarakatuh. Today I want to present about solar power up fan with IoT system based on carbon monoxide and temperature measuring for vehicle safety system. My name is Muhammad Syukur Adam bin Zahid from Bachelor of Electrical Engineering Technology from UC Tati, and my supervisor is TS Dr. Khairuddin Ali and CO supervisor is Dr. Hana binti Muhammad. I will start with my project background. Is the need for better car safety in Malaysia. So, as Malaysia has more cars on the road, safety becomes more important. Why people often think of accident, safety also includes danger inside the car itself. So this project was developed to improve passenger safety inside parked or idling vehicle. The system detects carbon monoxide (CO), gas level and cabin temperature in real time using IoT technology and solar energy for the backup battery. Okay, next is problem statement. The first is the slide explain the main problem that lead to the development of my project, which is an IoT-based carbon monoxide detection system with a solar power fan for vehicle safety. The first problem is carbon monoxide or CO. CO is a poisonous gas that has no color and no smell, so people cannot detect it easily. If a vehicle has poor ventilation, CO can accumulate inside the cabin. High level of CO can cause dizziness, difficulty breathing, unconsciousness, and in serious case is death. The second problem is high cabin temperature. When a vehicle is parked under direct sunlight, the temperature inside the cabin can increase very quickly. This is dangerous, especially for students, for children, elderly people, and pets. Excessive heat can lead to heat stress or even a heat stroke. The third problem is the most existing vehicle safety system only monitor one condition, such as temperature or gas. They also depend on the vehicle's battery and usually do not take automatic action when the dangerous condition occur. Because of this limitation, a smarter safety system is needed. Okay, next is objectives to solve my problem statement. First of all is to develop an IoT-based system that can detect both carbon monoxide concentration and temperature, integrate with a solar power ventilation fan for vehicle safety. Second is to monitor real-time carbon monoxide and temperature level inside the vehicle. Down IoT sensor and display the data including power consumption for solar panel on a mobile or web-based platform. Third is to analyze the effectiveness of the developed system in reducing carbon monoxide level, temperature, battery life supply for passenger safety inside the vehicle. Project scope and limitation. System purpose: detect carbon monoxide (CO) gas and monitor cabin temperature in a vehicle using IoT technology. Voltage output 0 to 12 volt DC. System design: compact prototype suitable for vehicle cabin environment. Supply source from PV solar panel 5 volt, 30 volt and charge 12 volt battery. And system limitation: performance depend on sunlight availability and air movement. Limited efficiency during low light or stationary condition. Temperature range 20 Celsius until 60 Celsius. For CO concentration, range 0 ppm to 1000 ppm for accurate monitoring. Okay, this slide show the list of material and the estimate cost for developing my project. The main component include the ESP32 Mini as the microcontroller, the MQ7 sensor to detect carbon monoxide, the DST22 sensor to measure temperature, and OLED display to show the reading, a solar panel and a 12-volt battery as the power source, relay module for control, and ventilation fans to remove hot air and carbon monoxide. The total estimate cost of all the component is 227 ringgit, which show that the system can be developed at a relatively low cost while providing important safety features. Okay, next is block diagram. This block diagram shows how my system works. It has three main parts, which are input, process, and output. First is input. The system receives data from the three sensors. The MQ7 sensor detects carbon monoxide, CO. The DST22 sensor measures the cabin temperature, and the voltage sensor monitors the battery voltage. Process. Next, all the sensor data is sent to the ESP32 microcontroller. The ESP32 compares the sensor reading with the preset threshold values and decide whether action is needed. Finally, the output. The sensor readings are displayed on the OLED display. If the CO level or temperature exceeds the safe limit, the ESP32 automatically turns on the blower fan and activates the TEC cooling system to reduce the cabin temperature and improve air circulation. Okay, next is this flowchart shows how my system operates from start to finish. Step first, the system is powered on using the battery and solar panel. Next, the ESP32 reads data from the MQ7 sensor to detect carbon monoxide, the DST22 sensor to measure temperature, and the voltage sensor to monitor the battery. The system first check the carbon monoxide level. If the CO level more than 10 ppm, the system activates the fan blower to improve air circulation in vehicle. If the CO level is safe, the system then checks the cabin temperature. If the temperature is above 35 Celsius, the TEC cooling system is turned on to reduce the cabin temperature. After that, the sensor readings are displayed on OLED screen and sent to the IoT platform for real-time monitoring. Last conclusion, the process repeats continuously to ensure the vehicle remains safe by monitoring carbon monoxide and temperature at all times. Okay, this is schematic circuit design for me. MQ7 gas sensor detect carbon monoxide, the ST22 sensor to measure temperature and relative humidity, voltage sensor to monitor voltage levels of power consumption, and solar panel OLED display show real-time collect data, voltage, temperature, CO level. Three fans turn on when temperature above 29 Celsius. One more fan turns on when CO got detect from 10 ppm in vehicle. Okay, next is project design and video. This is inside car and outside car. Okay, for development result, the graph show a direct inverse relationship between temperature and humidity. As the system temperature increase, the relative humidity consistently decrease. In short, as your environment get hotter, it also get drier. Okay, second is monitoring temperature. For temperature, the system temperature increases steadily from 29 Celsius to 40 Celsius over 30 minutes. For safety, carbon monoxide CO levels remain at 0 ppm without the test. The system response, the cooling system scale up from using one fan to three fans within the first 10 minutes. The battery used, the total battery consumption was 30.5% after 30 minutes of operation. Like you can see the table. Okay, this is the result I got. CO is lowest in the middle range of temperature and humidity. CO increase when either vector is too low or too high. Lastly, there is a clear optimal operating region for minimum CO. Okay, here the data is we check temperature, humidity, CO, and voltage for solar panel. Lastly is a conclusion. The project successfully developed an IoT-based vehicle safety system that monitor carbon monoxide, CO levels, and cabin temperature in real time, automatically activating a solar power exhaust fan and alarm to maintain a safe and comfortable environment inside the vehicle. By leveraging renewable solar energy and wireless IoT connectivity, the system provides the reducing risk of CO poisoning and heat-related incident. To further enhance effectiveness, it is recommended to incorporate additional air quality sensor, improve solar power safety capacity for operation in low light condition, implement predictive algorithm for proactive ventilation, conduct comprehensive field testing, and develop user-friendly mobile app feature for customizable alert and control. Okay, this show solar charge battery and battery to lamp. Okay, next is from outside. Okay, we can see in the side solar panel to supply to control the solar, and fan is too active. Okay, in LED OLED display show temperature is 33 and humidity is 73. Okay, the CO is not sure because do not have carbon monoxide. In this situation, we just read temperature only. Okay, so the fan active just 2 because temperature 33. The data we update every 1 minute in IoT Tinggal.io. Okay, that's all for me. Thank you.